Hey everyone, welcome to hok'stutoring. Hope you're having a great day. Today we are doing question 18, one of the very last question of chapter 12D. So your vector functions, vector calculus, and projectile motion question. Right, so the good thing about this question is part C. That's what I want to cover. But let's just do part A, B first, and then we'll go into part C. Right, so let's have a read. A particle moves in such a way that its position vector rt at time t is given by this position vector right here. Once again, only two dimension. I is your horizontal, j would be your vertical. Okay, and it's only between 0 to 2 pi. So normally you get t bigger than 0 and that's it. But this one, there is a restriction. It's only up until 2 pi. Now let's answer part A. Find the Cartesian equation of the path of the particle and sketch the path. Well, if you did 12a and b, guys, this is very simple. If you want to find the Cartesian equation of a position vector, or pretty much any vector right here, then you just let x equals to your horizontal function. So that's 4 cos t. And then you let y equals to your vertical function. So that's 3 sine t. And then you just want to get rid of the t because your Cartesian equation must be in terms of y and x only. So if you want to get rid of the t, we know that cos t sine t, there is the identity rule, cos squared plus sine squared equals to 1. So we want to get the squares up there first. Divide both sides by 4 and you get cos t. Divide this side by 3 and you get sine t. And then you square both sides and you get x squared over 16 equals to cos squared t. This side you get y squared over 9 and you get sine squared of t. You add them together, cos squared plus sine squared, you should get 1. So therefore, if you add x squared over 16 plus y squared over 9, you should also get 1. Okay, so x squared over 16 plus y squared over 9, that is equals to 1, just due to identity rule. Okay, so we need to also sketch it, so I'll just do a quick sketch over here. So horizontal, vertical axis, that's y, that's x, and that's fine. You can get, and yes, it's fine. You can also get negative x values, it's not t, and it's fine. You can get negative x values or negative y values, they're not timed. So this is your ellipse with a horizontal radius of 4, so negative 4 and 4. And then you also have a vertical radius of 3 and negative 3, okay? And then you sketch your ellipse down right here. Now, this is, luckily this question was from 0 to 2 pi, so it actually went one period. So the period of cos, both cos and sine is 2 pi, so it actually went one period, meaning you can just sketch the whole thing. So I'll just show you, do a quick explanation of why. Sometimes you might not be able to sketch the whole thing. So in this case, we know that t, so x equals to 4 cos of t, right? 4 cos of t, if you were to sketch your x-axis, so x values and t values, 4 cos of t means your cos graph looks like this. It can go from 4 to negative 4. So x values, because t can take up till 2 pi, it can take all these values right here. So that means your x, the range of this graph can be from negative 4 to 4. You can take any x values. Now, if I restrict this t so to maybe like only from 0 to pi over 2, so pi over 2 being only here, then that means your x value cannot be negative over 0 to negative 4, okay? Because if you only go from 0 to pi over 2, the only x values you can take for those t values given to you, if they changed it, can only be from 0 to 4, okay? That's what it's this graph is telling us. But because it's 2 pi, we want one period, it just takes the whole thing. Same thing with the y equals to 3 sine of t. So if you to sketch that right here quickly, you get your sine graph, amplitude is 3, meaning you get 3 and negative 3 as your max and min. See, because it's 2 pi, you can take all the possible y values that this graph gives you, okay? So negative 3 to 3. But if you do restrict it, so maybe 0 to pi 2, once again, 0 to pi 2, then you can only go from 0 to 3, okay? But in this case, just take everything. That's fine, you get your typical ellipse. So that's part A, guys. I'll just do part B underneath here, just a little bit quickly. Part B, I find when the velocity of the particle is perpendicular to its position. So find when the velocity vector is perpendicular to position vector. How do we do that? Well, let's get the velocity vector up first. So Vt, we just differentiate our position vector. We get negative 4 sine of t, I, and then plus 3 cos of t, j. Okay, so that's your velocity vector. And now we want our velocity vector to be perpendicular to our position vector. How do we do that? Well, vector says, the rule, the dot product says, if the dot product of your velocity vector or one vector between and another vector, so your position vector is equal to 0, then they are perpendicular. So let's have a go. Velocity vector negative 4 sine t I plus 3 cos tj. If you dot product with this vector right here, 4 cos t I plus 3 sine tj, just multiply the coefficient respect independently. So the I times the I and the j times the j, okay? So negative 4 sine t multiplied by 4 cos t, and you should get negative 16 cos t, but then also sine t, okay? And then you add your coefficients together, 3 sine t multiplied by 3 cos t, and you get 9 cos t sine of t, and then the I and the j disappears. We want to make that equals to 0, okay? So you make it equals to 0, add the vector, add the terms up. Because they have the same term, cos t and sine t, you can just add the coefficients. We get negative 7 cos t sine t equals to 0. And of course, we need to solve for the time when that occurs, right? So if you want to do that, we let cos t equals to 0 or sine t equals to 0. Any one of these, if they equal 0, would get you to 0, okay? So when is cos t 0? We just draw a unit circle quickly over here. Cos t is 0 when it's up here or down there. So that means t equals to pi on 2 or 3 pi on 2. And then of course, sine t, your t values, your sine is 0 when it's horizontal, so the right and left. So that means t equals to 0, t equals to pi, and t equals to 2 pi. And we stop there, we don't go anymore because our domain for t says you can only be from 0 to 2 pi. Okay, so that's bi. That's where you find when the velocity is perpendicular to its position. Okay, and then double I, find the position vector of the particle at each of these times. Well, that's really quick, guys. I'll speed up the video at this section. But if you want to find the position vector at all of those times, really all you have to do is just sub in 0, sub in all your times right here. So you sub in 0, you sub in pi on 2. Really, guys, just put inside your position vector. I don't think this one needs much of an explanation, okay? Right, now moving on to part C. Find the speed of the particle at time t. So if you want to find the speed, you need to get the velocity first. So we know the velocity vector as found in part A and B previously. Just differentiate your position vector. I'll write that down quickly. Now, if you want to find the speed, you just need to get the magnitude of that. So magnitude just means square your coefficient. Square of negative 4 sine t gives you 16 sine square t. And you square the other coefficient, you get 9 cos square of t. Okay, so that's your part CI. That's how you find your speed and in terms of time. Now, double I says do the same thing, but in terms of only cos square. Now, if you look over here at your initial speed, it's in terms of sine square as well. How do you convert sine square into cos square? Well, we have the identity rule, right? Sine square of t plus cos square of t equals to 1. That means sine square of t equals to 1 minus cos square of t, meaning 16 of that will just give you, so 16 sine square of t will just give you 16 minus 16 cos square of t. Okay, so we write that down over here. Magnitude, that means speed of the velocity. So that is equals to the square root of 16 minus 16 cos square. That's what our 16 sine square looks like. And then we just add it up with 9 cos square of t. Okay, now very simple. Let's just move the square root a little bit over. We get square root of 16 minus 7 cos square of t. Perfect. So that is your speed, which is the magnitude of your velocity. Let's do triple I, the one I want to get into. State the maximum and minimum speeds of the particle. There is a long way of doing this, guys, but there's a shortcut which I will show you. The long way of doing this, you differentiate the whole thing in your calculator, let it equal 0, find on your graph where the maximum is, but as you can see, that can be pretty tedious, okay? If you want to do it the short way, then we take advantage of the fact that the only thing affecting the speed here is this cos square t, okay? Cos square of t is the only thing affecting your speed. So whatever t is, you get a cos square, that number will then affect these numbers right here. That cos square right here would be the one that changes your speed, okay? That's the only variable. Everything else is a constant. So how do you get max speed? How do you get minimum speed? We know the cos square graph looks like this. So cos square of t. If you don't, then you can, I guess, give a rough sketch, but if you were to sketch it, it looks like this. So just ignore the 7. So I know amplitude is 7, but we're just going to use cos square t, okay? It's going to look like this right here. It's pretty much the wave again, but it never goes down. The cost graph typically would go down, but this one doesn't because it's squared. So the maximum occurs when it's 1, minimum occurs when it is 0. So cos square max occurs when it's 1, minimum occurs when cos square is equal to 0. Now the thing here is you have square root of 16 minus this graph right here, okay? Because there's a minus, we take into account the minus as well, okay? So I'll sketch the minus, the negative cos square. So let's try it. Negative cos square, it's pretty much this graph right here, but reflected the other way. So that means it starts from -1, goes over to 0 right there, and comes back down right there, and it just keeps going on, okay? But in this case, the max occurs when your negative cos square, so the max occurs when the negative cos square t is equals to 0, see, the max occurs over here, and the min occurs when your negative cos square t is equals to -1. So how does that work? Well, we know that this max, the max of the speed occurs when your cos square t, negative cos square t is equal to 0. So what we do is, if you want to find the max speed, then it's just square root 16 minus 7 or plus 7 times by your negative cos square when it's at the max, okay? So times by 0, and you get root 16, which is just 4 meters per second. Now if you want to get the min speed, very simple as well. You square root 16 plus, and then let's have a look over here. Your min speed occurs when your negative cos square t is -1. So negative cos square is -1, okay? So -1 times 7, I forgot to multiply by the 7 on the outside, so that should be 1, okay? So 16 minus 7, that gives you 9 square root of 9 is 3 meters per second. So that's your minimum speed, guys. So it's very simple. Do not differentiate. Just use a bit of logic. You know, when negative cos squared t is 0, you get max. And when negative cos squared t is -1, you get a minimum. Okay, and it applies overall throughout the speed. So that's how you answer this question, guys. Question 18, chapter 12D. Hopefully you found this video useful. And if you did, please leave a like and a thumbs up. Aside from that, guys, thanks for watching, and I'll see you in the next video.